All right, so this is assignment number 3, and it's a JDBC. It's an opportunity for you to practice JDBC. It uses the same exact UML class diagram from the previous assignment, but now it asks you to basically do all the same interactions that you did for the previous assignment, where you wrote all the scripts to create the schema, to do all the inserts, all the updates, or the select statements, or the deletes, the views, and whatnot. So it asks you to do pretty much the same thing, but now using JDBC. All right? It's the same UML class diagram. It gives you just a couple of blurb on how to implement one-to-many and whatnot. And it asks you to create a Java version of the data model. Right? So we did most of the grunt work already in the previous assignment. Right? We presumably somebody had given us a problem statement. We had decided on how we were going to break it up into multiple tables. We had normalized the structure, and we had already decided on these classes, right? And these relationships between the classes. In Java, it pretty much is going to follow the class diagram. So for each class, there will be a Java class. So for every single class that you see in the class diagram, there will be an equivalent Java class. And so all the attributes that you see in the classes in the class diagram would be readily available in the Java classes: person, user, developer, website, and whatnot. Plus all the relationships between them, right? So for instance, just like the class diagram implements inheritance between person and then user and developer, these two, right? The user and developer are going to inherit from the person. Just like there'll be a base class widget that will be that several other widgets will be inheriting from, right? So this will mimic very closely the class diagram that we designed earlier. We're asking you to provide certain types of constructors for us, since the TAs are going to create some JUnit tests to validate your code. So they'll be expecting certain constructors. Right, because so they need to be able to instantiate your instances to try it out and see if it works. We're also asking you to follow a naming convention on what to call the database, what to call the project, what to call the package names to use. So please follow these naming conventions. Again, the tests that the TAs are going to be writing are going to assume this package structure. Okay, so for instance, we're asking you to use the edu.northeastern.cs5200 package and do all your work under there. Okay, and also the name of the project should be called CS5200 Fall 2018, and so on and so forth. Also, there should be dedicated packages called DAOs and models, where you're going to put your data access objects and where you're going to put all these Java classes that you're going to be implementing. Okay? If you have other packages for other classes, utility classes that you might want to create for yourself, you're welcome to create your own, right? As long as you adhere to these specifications, right? You're welcome to create other things that are not specified, right? Here we give you a sample on how to manage the database connections as a singleton, where you have a single connection that is shared amongst all the rest of the application. So we want you to encapsulate the life management of the connection to a database through this class, the connection class. So this will be the single place where we open up a connection to a database, and we're going to keep it around. Right? We're not going to close it. We're just going to leave it here and use it whenever we need it throughout the application. And then we don't need it anymore. We'll close it down and release it. Okay, so we're giving you a sample implementation here. Right? Please include the username and password in the source code. Typically, you would not put it in the source code. You put it like an environment variable or some property file and whatnot. But for us to be able to reuse your code, we need the credentials here. Okay? Yes. There was a challenge on being able to create procedures that we were not able to do it on Heroku. So that's why we were moving over to AWS. Yeah. If you can get procedures working on Heroku, would love to hear it. All right, so additionally, we ask you to create these data access objects. These are classes, Java classes, singleton Java classes that are going to encapsulate, modularize all the data access, right? So whenever you're going to be interacting with any one particular table or entity, as the conceptual name for a table might be an entity. All those operations should be encapsulated in a dedicated DAO, right, data access object. So any access to a person, a course, a widget, a user, a developer, all the CRUD operations, create, update, delete, they should be all encapsulated in each one of these DAOs. All right? And we'll talk about implementing them today. We also ask you to implement the following. So for the developer impl, the DAO, we ask you to provide implementations for these following methods. Be able to create a developer, find a developer by ID, find all the developers, find a developer by credentials, find a developer by username. Notice the naming convention. Notice that these are all the CRUD operations that you would expect in a data access object. All the ways that you can interact with a particular table. Right? You need to be able to create it, read from it, update it, delete it, and when you're retrieving data, there might be multiple criteria by which you retrieve all the data. Right? You can retrieve all the rows, you can retrieve a single row, or you can retrieve rows that meet a particular criteria. All right? So the first two here, the find all developers and find developer by ID. And they allow you to retrieve all the developers or retrieve a single developer. Notice the naming convention. The create, they all start with create. So there will be create developer, create widget, create user, create whatever. So it's create followed by the name of the entity that you're interacting with, right? And presumably this would do an insert into a database. Okay. Then these find methods, they all start with find, and they're usually referred to as finder methods. And there could be any number of finder methods. Two of them are very common. One allows you to retrieve all the records, whereas the other one allows you to retrieve an individual record. Right? If I know the primary key, I can retrieve a single record. All the other finder methods are based on a particular criteria. This one is find developer by username. So presumably you give me a username, and I'll retrieve that particular record that has that username. Another one here is find by credentials. So presumably you give me a username and password, and I'll find that person by its credentials. They all start with find developer, find developer, find developer, right? Or developers, okay, depending on what you're using. Plus you have here update developer and delete developer. And so the same thing for website, for page, for widget. So we ask you to create all these DAOs for each one of the entities. Okay? All right. What else? We're asking you to use the same exact data that you used for the previous assignment. Right? That we'll ask you to insert all these folks. Insert all these. So using the DAOs you just created, you're going to exercise that DAO by inserting, updating, deleting, retrieving data, just like you did for the previous assignment, but now using jdbc. Okay. And finally, the last question is to create a store procedure. Right. This is why we had to go with AWS. You need to create a couple of store procedures that interact with the following data model. So this is the same user data model that we had earlier, and the same widget we had on the left-hand side. So that's the same widget we had in the previous class diagram, plus the same user that we had in the class diagram. Here, we're adding two new widgets. Okay, the question widget and the answer widget. So the question widget would allow any user, to post a question on the website. Very much like in Piazza, right? Anybody can post a question. So anybody can post any number of questions. So there's a one-to-many relationship between a user and a question. And then somebody can answer that question. Somebody else, it could be the same person, can post an answer to that particular question. Okay? So you can post any number of answers. And you can post it for a particular module. So the two queries are, using the DAOs that you implemented already, provide the following functions that are going to use JDBC to use the store procedures, to call the store procedures that are implemented in the database. So the database will have a store procedure, and from JDBC, we're going to call that store procedure. Okay? So it's going to execute, but running it from JDBC. One of them is get unanswered questions. So the store procedures needs to be able to retrieve or calculate which questions have not yet been answered. Right? And this will return a list of unanswered questions. And then you can also calculate the endorsed users for the week. Right? So a faculty can endorse a question saying, folks can upvote and folks can downvote a particular question. Right? And faculties can endorse a particular question or answer. Right? So this one returns for the given week where we are, retrieve all the endorsed users for that week. Okay? All right. Any questions? All right.